Let me start with a real story. A security researcher recently found a way to hack ChatGPT accounts using nothing but a clever URL trick. No malware, no password guessing, just a URL. Because of this trick, he was able to expose session tokens, personal data, and even billing information. And the scary part, anyone could repeat the same threat if the system was not fixed in time. So in this video, I will break down how this attack works in simple words, show you a live demo, and then show you how to fix it the right way. Let's jump in. What is web cache deception? Before we get into the attack, let's understand the idea behind it. On the internet, websites use caching to make things fast. A cache stores files like images, CSS, and JavaScript so that server does not have to generate them again and again. This makes the site load faster, reduces server load, and saves money. Some content is static like images or style files. Some content is dynamic like your profile data or account details. Static content can be safely cached, while dynamic content should never be cached because it changes per user and often contains private information. Web cache deception happens when the cache gets confused and stores private dynamic content as if it were a static file. In one line, web cache deception is when the server mistakenly caches sensitive user-specific data and makes it available to the public. Here is a simple picture of how things normally work. In normal flow, user data goes to CDN, to application server, and CDN stores static files. Public users loads the data from this cache. But when things go wrong, the cache ends up storing things it should never store, like your profile, tokens, or private data, and makes them available to anyone who hits the same crafted URL. This tiny mistake opens the door to huge security problems, including account takeover. Now let's see how this attack really works step by step. First, think about a normal private page like account profile. This page shows your name, email, maybe even a session token. You must be logged in to see it. The server builds this page just for you, so it should never be cached and shared. Now add a CDN in front of the app. The CDN has simple rules like cache everything which is under a static folder, or cache any URL that ends in .css, .js, or .png. These rules are made for speed, not for security. The attacker's goal is to make the victim visit a special URL that still reaches the private endpoint but looks like a static file to the CDN. For example, account/profile/mystyle.css. So here is what happens behind the scenes. The attacker sends this special link to the victim or gets the victim to click it when they are logged in. The victim's browser sends a request for that URL to the CDN along with their cookies. The CDN looks only at the shape of the URL, that this URL ends with the .css or it starts with /share, so it decides this is cacheable. The CDN then forwards the request to the backend server. The backend server does not care about the .css part of the encoded path trick. It decodes and routes the request to the real endpoints /account/profile or API authentication session. The server sees the victim's session cookie, thinks this is a normal logged in user, and returns private data like profile info, token, session details. The CDN now gets this private response and because of its rule, stores it in the cache under that exact URL. That is the key point. The CDN caches the response because of its rule, not because it knows the data is private or public. It only sees this URL looks like something I should cache. Now comes the third phase. Later, the attacker visits the same URL, which is, for example, account/profile/mystyle.css. This time, the CDN does not go to the backend. It sees the URL, finds it in the cache, and returns the stored response. The attacker now gets the victim's private data from the cache even without being logged in. No password, no session cookie, just a clever URL that was cached when the victim first opened it. So this is what happened in the ChatGPT account takeover case. The researcher used an encoded path that CDN treated as cacheable share URL. The backend decoded into a real sensitive endpoint for session data. Because the CDN and the backend did not treat the URL in the same way, the CDN ended up caching session information and serving it back later to anyone who hit that URL. One bad cache rule, one smart URL, and private data became public. So what does this attack actually lead in the real world? The most serious impact is account takeover. If someone gets your session token, they can log in as you without knowing your password. It also leads to session hijacking, where an attacker can reuse your active session and access everything you can. If the leaked data includes your name, email, billing address, or payment details, that becomes PII exposure and opens the door to many other risks. And this is not just theory. The ChatGPT bug we talked about earlier earned the researcher more than $6,500 USD in bug bounty rewards. That was because the impact was real, serious, and easy to trigger once the mistake was found. Now comes the second phase. Let's move from theory to action. I will show you the web cache deception attack on a small demo app that I built. This app has a login page, a private profile page, and a fake CDN cache that behaves just like a real system. So first, I will try to log in as a victim user. So this is my profile with session token. This part is normal. So now I have an incognito mode open, and here if I visit to this URL, it will show me that I'm not authorized to see anything on this URL because I am not logged in, which is normal. So what these red buttons does is they will store the shown URL like demo.css into the cache, private profile data. So if I click here, these are the information which are stored in the cache. Now if I go to in private window again and refresh it, I can see my email, a user session token, and other profile information which should be ideally private to me. This means the CDN simulation thinks this is a static file and decides to cache it. But the backend server still returns private profile data because it ignores demo.css part and treats it like a real profile endpoint. And here showing the private data means that it did not contact the server. It simply returned the cache response from earlier. And on screen we can see the victim's private profile data even though we are not logged in. No session cookie, no password, just cached private data served to anyone. This is the exact flow used in real web cache deception attacks. Now let's look at the code that makes this demo vulnerable. I'll show you exactly where the mistake happens and why it leads to private data leaking through the cache. Let's start with cache.js. Here we have simple in-memory cache that acts like a CDN. It has a list of cacheable file extensions .css, .js, .png, and so on. It exposes three important functions. Is cacheable URL, checks if the URL ends with a cacheable extension. Get URL, returns cached data if available. And set URL, stores the response under the full URL. This is already a problem. The cache decides what to store based only on the URL extension, not what the data actually is. So if you visit something like account/profile/demo.css, the cache sees .css at the end and says, oh great, a static file, let me store this in cache. It never checks whether the data is private, dynamic, or user specific. Now let's open server.js. The key vulnerability is in the cache middleware. It watches all requests that start with account/profile. Inside this block, it does something dangerous. It checks if the URL is cacheable using only the file extension. If yes, it tries to serve the cache response. It does this even for users who are not logged in. This is the heart of the web cache deception issue. The middleware does not check authentication before serving cache data. If the fake URL is visited by the victim first, private data gets stored. Later, the attacker gets the same data from cache without logging in. That's exactly how the exploit works. Now, if we scroll down a bit and we will see this root account/profile/star. This wildcard root catches URLs like account/profile.styles.css. What makes it even worse is that it sits before the safe root. It allows the server to return private data for paths that look like static files. If the user is logged in, the server returns their private JSON file, and this response gets intercepted and cached by the middleware we saw earlier. If the user is not logged in, the middleware may still serve the cache response. This is the exact moment where account takeover becomes possible. Now let's talk about the fixes. The good news is that this vulnerability is easy to prevent once you know where the problem comes from. The first rule is simple: never cache pages that need authentication. If a page returns private or user-specific data, make sure it always bypasses the cache. Next, set the right headers on sensitive endpoints. Your server should send headers like cache control, no store, no cache, must revalidate, and private. These headers tell any cache, CDN, or reverse proxy that the content must not be stored or shared. You should also whitelist only true static content like .css or .png. Instead of saying cache anything that ends with .css, you define exactly which folders and files are safe to cache. This prevents attackers from creating fake URLs that trick the cache into storing private responses. Another key point is to make sure the CDN and the backend server treat URLs the same way. If one layer ignores encoded paths while the other decodes them, an attacker can find gaps between the two. Consistent URL handling removes these gaps. Also, avoid relying only on file extensions to decide what is cacheable. Extensions can be faked, paths can be misleading. Attackers know this and take advantage of it. And finally, test your app by trying encoded paths, extra directories, and strange URL patterns. If you can reach a sensitive endpoints through a weird-looking URL, you may have a cache rule that needs to be fixed. By following these steps, you can close the door on web cache deception and make sure your app serves the right content to the right user every single time. Let's wrap this up. We learned that web cache deception is how one small mistake in caching can leak private data and how attackers can turn that into a full account takeover. You also saw the demo in action where a simple crafted URL exposed sensitive information through the cache. And the good news is the fixes are simple. A few right headers, clear cache rules, and proper URL handling can prevent all this damage. If you enjoyed this breakdown and want more real-world cybersecurity demos, make sure to subscribe. Thanks for watching, and I will see you in the next one.